This equation right here gives us the amount of time it takes to reach the peak of your projectile. And you have to recognize two things. First off, there's going to be no vertical velocity when you reach your peak. The reason why is because this is the split second before your object starts falling, but it's also the split second after your object travels up. So just for a brief period of time, your velocity in the y direction is going to equal 0, right here or here. Another thing you have to recognize is that gravity is going to be negative, because gravity is pulling your object down. So let's go ahead and see if we can solve and get this expression right here. So we know that acceleration is equal to a change in velocity over time. And if we're dealing in the vertical direction, that's going to be negative g for your acceleration. And that whole thing's going to equal your final velocity in the y direction, because it's vertical, minus your initial velocity in the y direction, divided by time. Multiply your time on both sides of the equation. This will get the times to cancel, leaving you with negative g times t equals v final y minus v initial y. You can add the v naught y on both sides of this expression. What this will give you is v final y equals v initial y minus gravity times time. Now, like we said before, this is going to be 0 when we reach our peak, and our final velocity is going to be at the peak since that's what we're trying to calculate. So we have that 0 equals v naught y minus gravity times time. We can subtract the velocity initial in the y direction from both sides of this expression, leaving you with negative v naught y equals negative gravity times time. So what we can now do is take this negative g and divide it on both sides. That'll get the g's to cancel here, leaving me with t equals, and these negatives will cancel, which will be v naught y all over gravity. Now, v naught y can be calculated by taking your initial velocity and multiplying it by the sine of your angle theta. The angle theta will typically be given to us. So the final equation is going to look like this. V naught times the sine of theta divided by g, which is going to be 9.8 on Earth. So this equation here will calculate the peak, and that makes sense since that was the same equation we had before.